we are going to continue our lesson on measuring angles, and today we'll talk specifically about the angle addition postulate. We'll also talk about congruent angles and angle bisectors. So first, the angle addition postulate. If P is in the interior of angle RST, so here is angle RST, and P is in the interior. So we've got another ray in here with point P. Then the measure of angle RST is equal to the sum of angles RSP and PST. Okay? Now, you may recall the segment addition postulate. This is a lot like that. The segment addition postulate looked like this. We've got A, B, and C. Then the length of segment AB plus the length of segment BC equals the length of segment AC. Okay? So that is the segment addition postulate. The angle addition postulate says that here, angle RSP, if I add that measure to angle TSP, so the measure of angle RSP plus the measure of angle TSP equals the measure of this outer angle, angle RST. Okay? So this little M and that symbol means the measure of the angle. The measure of angle RSP plus the measure of angle TSP equals the measure of angle RST. Okay? Now on our next page, we will use that formula. Okay, so given that the measure of angle LKN is 145 degrees, so this outer angle here is 145 degrees, angle LKN. Find the measure of angle LKM and the measure of angle MKN. Okay, so this big outer angle is 145. I want to know the measure of each of these two angles. The segment addition postulate tells me that I can add these two angles together and say that their sum is equal to the measure of the outer angle. So that means 2x plus 10 plus 4x minus 3 is equal to 145 degrees. Okay, so these two degree measures equal the outer degree measure when I add them together. Now I can just combine some like terms. I've got 2x and 4x, so that makes 6x. 10 and negative 3 makes 7, so 6x plus 7 equals 145. Okay, so 6x plus 7 equals 145. I can subtract that 7, and I get 6x equals 145. And then I can divide both sides by 6. And here's where you might want to use a calculator, but 138, I'm sorry, I didn't subtract that there. 145 minus 7 is not 145, it's 138. And 138 divided by 6 is 23. Okay, so now I know the value of x, and I can plug that into each of these two angles to find their measures. So the measure of angle LKM is 2 times 23 plus 10. Okay, so that is 46 plus 10. So the measure of angle LKM is 56 degrees. Okay, then I can put that 23 here in MKN. So the measure of angle MKN is 4 times 23. Sorry, my camera just quit on me there, so I'm not really sure where we left off, but the measure of angle MKN is 4 times 23 minus 3. So 4 times 23, okay, that is 92. And 92 minus 3 is 89. So the measure of angle MKN is 89 degrees. This next one doesn't exactly tell us an angle measure, but it says that angle KLM is a straight angle, and a straight angle makes 180 degrees. So I can add these two together, so 10x minus 5 plus 4x plus 3 equals 180. 10 plus 4, that's 14, 14x. Negative 5 plus 3 is negative 2, equals 180. Okay, now I've got a minus 2, so I'll add 2 to both sides, and I get 14x minus 2, 14x equals 182. Okay, and then 182 divided by 14, that is 13. X equals 13. Okay, now I will plug that 13 into each angle. The measure of angle KLN. Measure of angle KLN equals 10 times 13 minus 5. So that's 130 minus 5, and that is 125 degrees for the measure of angle KLN. The measure of angle NLM is 4 times 13 plus 3. Okay, 4 times 13 plus 3, that is 55 degrees. Now, there is a quick way to check and see if we're doing these right. I could put in my calculator 56 plus 89, and that better add up to 145. If it doesn't, then I made a mistake. And then I could do 125 plus 55, and that should add up to 180, as long as I did it correctly. Okay, now here I have a right angle, and a right angle is 90 degrees. So this time, 2x plus 2 plus x plus 1 is going to equal 90 degrees. Okay, so when I combine my like terms, I'm going to get 3x plus 3 equals 90, and I'll subtract 3, so 3x equals 87. 87 divided by 3 is 29. So I know that x has a value of 29. And I can plug that in to angle EFH. The measure of angle EFH is 2 times 29 plus 2. Okay, 2 times 29, that's 58, plus 2, we've got 60 degrees. And then x plus 1 for angle HFG. The measure of angle HFG equals 29 plus 1, and that is 30 degrees. And I can add those two up. 60 plus 30 is 90, so that means this was done correctly. So that is the angle addition postulate. Now, congruent angles are angles that have the same measure. Okay? So that could look like this. Here's an angle, here's another angle, and I could put a little arc in each angle. The fact that they both have one arc tells me these angles have the same measure, so they are congruent. Now, if I put two arcs in this one, but only one here, these angles are not congruent. They have different measures. Now they are congruent because they have the same number of arcs. It could look like this. I could write in 30 degrees here and 30 degrees here. They have the same measure, therefore they are congruent. Now I'll call this angle A and angle B, and it's okay to just name these by the vertex because there's only one angle in each diagram. So I could say angle A is congruent to angle B. Okay, angle bisector is a ray that divides an angle into two angles that are congruent. And I'm just going to write the symbol instead of the word. A ray that divides an angle into two angles that are congruent is an angle bisector. So if I have an angle with another ray here, and I say that these two angles are congruent, then that means this is an angle bisector. All right, in this image, we need to name some angles that are congruent. So we're going to identify any congruent angles. Okay? So here I have one arc. That arc is inside of angle D, E, F. Here I also have an arc, so I know that it's going to be congruent to this angle. So angle D, E, F, remember when you name an angle, vertex goes in the middle, is congruent to angle L, K, J. Okay, so that's a pair of congruent angles. Now these two each have two arcs. So that means angle DEG is congruent to angle LKG. Okay, so those are my congruent angles. Now, what if angle DEG is 157 degrees? What's the measure of angle GKL? Well, since they have two arcs, they are congruent to each other. That is also 157 degrees. So the measure of angle GKL is 157 degrees. Identify all pairs of congruent angles in the diagram. Now, each angle has only one angle at each vertex. There's not like an extra ray inside that would split any of these angles up. So I can name angles here with only one point with the vertex. Because these each have one arc, I can say angle T is congruent to angle S. Because there are two arcs here, I could say angle P is congruent to angle R. Okay, now in that diagram, same picture, the measure of angle PQR, now this uses three letters, Q is the vertex, the measure of angle PQR is 130 degrees. The measure of angle QRS, vertex at R, is 84 degrees. And the measure of angle TSR is 121 degrees. Find the other angle measures in the diagram. So I can use my congruent angles to say that T and S are the same. So the measure of angle T is 121 degrees. P and R have the same measure, so the measure of angle P is 84 degrees. in this diagram, ray YW bisects angle XYZ, so it cuts it in half. These two are congruent angles. The measure of angle XYW is 18 degrees. Now that tells me that this side is also 18 degrees. Find the measure of angle XYZ. So we're going to put a couple things together. First, we're talking about an angle bisector, which means we've got congruent angles. So that's two of our vocab terms today. An angle bisector gives us two congruent angles. And now we can use the angle addition postulate to find the measure of angle XYZ. We can simply add 18 degrees plus another 18 degrees to get the measure of angle XYZ, and that is 36 degrees. And last, the measure of, angle MNP is a straight angle. And ray NQ bisects angle MNP. Draw angle MNP. So we'll call this angle MNP. It is a straight angle. And ray NQ bisects it. Okay, so this is 180 degrees. If ray NQ is going to bisect this angle, that means I'm going to have 90 degrees on each side. That will go straight up this way, or it could have gone straight down the opposite way. Okay, and it's going to give me 90 degrees on each side. I've got two right angles. Use arcs to mark the congruent angles. So I could put an arc on these two because they are congruent to each other, and give the angle measures of these congruent angles. The measure of angle MNQ is equal to the measure of angle PNQ. Both of them are 90 degrees.